As already mentioned, I'll be talking about commodified infrastructure as a code using Terraform Cloud today. First of all, I have to say I'm really happy to see all different people logging in from different time zones, and I'm really excited to be part of this year's HashiTalks. So without wasting any more time, let's just get started. So we are all kind of familiar what common commodities are. If we start with the most basic kind of economical definition, they are goods or services that are, that market kind of treats all of their instances equally. So for example, we have all different commodities like, grains, coffee, oil, and maybe in water. They're most commonly used in our everyday life. And probably the most kind of, let's say, widespread commodity in the developed world would definitely be electricity, we are all familiar with. So electricity was not always kind of a commodity that we now see nowadays, where it's used in computers, phones, light bulbs, or even heating. Probably our presentation today wouldn't be here without electricity. But it came all the way long way from, from initial inventors like Franklin and Tesla. Then we gradually started kind of spreading it around, lighting up our streets, spreading around the biggest cities. And nowadays it's being widely distributed among, every place you can even imagine, like from our homes to trains and planes. It's available, the sockets are available like literally everywhere nowadays, and you can just use it without even thinking how it got there or how it was even produced. So if we quickly just have a look of how solutions or products are refined, we can really well use their Simon Worley's value chain mapping graph, which really kind of very well represents how the solution goes through different kind of evolutionary phases there, all the way from the original genesis, then through the custom build, and eventually, if it's kind of widely adopted, it becomes a product, and at the end of it, it usually ends up as a commodity, as we talked before about electricity. So it's just available there for us without we have to think how it got there. As we travel this path, we kind of gain a lot of knowledge. So of course we know how electricity is made in general, but it's not something that we should be kind of, aware of or need to do it on an everyday basis. But as we follow the whole value chain there, like every product or solution, we also have to be aware of different perspective there, which is not just the different evolutionary phases, but also the adoption of products, which is quite well represented with Gartner Hype Cycle. This kind of very well illustrates how usually software is adopted nowadays. So you would usually have this big positive hype at the beginning, followed by a negative hype afterwards with the realization and disillusionment, as they call it. And then eventually, gradually kind of progresses forward over the productivity plateau. And I think that Terraform as a representation of infrastructure as a code is kind of getting forward towards nowadays. So throughout the next couple of slides, I'm just going to try to show how this is happening. And we hopefully going to see at the end of the presentation that we are really stand nowadays with Terraform and Terraform Cloud specifically. So just before we continue, a little bit about me. I work as a senior IT consultant at Scale Factory. We are a DevOps consultancy based in London. We mostly work with AWS Cloud, and we kind of help teams get more efficient with either embracing or optimizing their workloads there. We're also a Kubernetes service provider, and my background is actually an ops background. I have an extensive Linux and virtualization experience. and I work with the Hashi stack on a daily basis. I'm also an open source contributor and a supporter, and big fan of automation, hiking, cycling, and traveling. So let's quickly look at the talk agenda, what's there in front of us. So first, I'm gonna quickly just kind of briefly talk about infrastructure as code. Then we're gonna start with our main topic, which is Terraform Cloud. Just gonna go quickly over how it all kind of compares to the OSS client CLI Terraform. What are the differences? Afterwards, we're gonna do a little bit more of in-depth talk about how it abstracts complexity and how it integrates with existing or new CI/CD systems and pipelines we might have in place, and how we can actually automate the whole process of deploying our infrastructure as a code. All will be followed by a live demo. So fingers crossed that the demo gods are happy today. And we're gonna kind of take it away at the end with some conclusions and takeaways. And if you decide to go with the Terraform Cloud solution, what you should be kind of aware of or careful, or at least what were our experiences there while we were using it on our end and for our customers. So, as I mentioned, what is infrastructure as a code? It's definitely what it says on the tin. It's a code representation of our infrastructure. As already Anton said before, it's kind of a way of how Terraform is representing our infrastructure, or at least trying to do a fair representation of what it's going to look like after we apply that code. It's definitely the key attribute for enabling good DevOps practices. For example, like breaking organizational silos, or encourages multi-team collaboration with the code that we can easily share between team members, and we can all collaborate on the initial deployment or afterwards changes. It definitely increases the state visibility across our estate. So when we are sharing a code, we can easily just look at the code and see what our infrastructure looks like before we actually have to go and check either the cloud vendor console or any other kind of monitoring system in order to see how it actually looks like. It also helps us kind of deploy, like I mentioned, our reproducible and disposable infrastructure, which is also kind of the key element of DevOps practices nowadays. And as it was also mentioned in the previous Anton's presentation, it helps us have higher cadence of deployment cycles, and of course, it's kind of, let's say, lubricates the automation process of delivering our infrastructure. And of course, last but not the least, it kind of improves our testing of our infrastructure. Of course, we had several spec tests before, but with infrastructure as a code, there are different ways of how we can better test our infrastructure even before deploying, and lowering the risks of later errors that might occur in the deployment pipelines. So, as I mentioned, Terraform Cloud, shortly what it is, it was announced, I think, last year at HashiCorp 19. It was also made generally available at this point. It's an extensible SaaS solution. It used to be called Terraform, I think, Enterprise in the past, which was kind of rebranded to Terraform Cloud now. There is still an enterprise package you can go for, but if you, which I think it's deployed on premise, but if you go for the SaaS solution, which HashiCorp offers, it's called Terraform Cloud. it's a very nice abstraction of all the Terraform complexity that comes with using Terraform nowadays. Definitely, it offers you a safe kind of a cloud solution for managing your Terraform cycle. You can use many different safety factors as two-factor authentication, secrets all in the background. They're managing secrets using their own in-house solution Vault. Like I mentioned, it's really good for the collaboration with other team members. For example, it has a really good version control system integration, supports notification, has a nice web UI that probably most of the people starting using Terraform are missing. And of course, there's a standardized set of APIs that you can use when using Terraform, either in OSS CLI mode or cloud Terraform cloud solution, which is an offered as a service. You can also use fine-grained controls in a way that you can apply different code policy to this. It's part of the Sentinel policies that Terraform uses, which most of the users are familiar from the enterprise solution in the past. You can set different user roles for your organization, and there are also kind of nice features as cost estimation, which kind of predicts what the cost will be or what the change of your monthly bill will look like after applying your infrastructure. And of course, as I mentioned, it's an extensible and very kind of open platform, and also supports over 160 available providers. I think this number might be much higher than since I last looked. So let's quickly just look over how Terraform Cloud architecture looks like, specifically comparing to the, like I mentioned, OSI's CLI option that most of the people start with. So in the OSI CLI kind of, let's say, process that you would use, you would usually have your infrastructure as a code, most usually stored somewhere in a repository. You can either use or not use kind of different external modules, and then usually you would plan and apply, and this would be then deployed to whatever cloud vendor or different kind of provider you use, and doesn't even have to be a cloud vendor. It can be basically anything. So if we look at the right here, how the cloud Terraform, if you're using Terraform Cloud, how the architecture looks like in that case, it actually, from the user perspective, it looks almost the same. You can still use the CLI, but the difference is you can use, as I mentioned, VCS integration, which can trigger your pipelines or detect code changes. But in this case, Terraform Cloud kind of encapsulate the whole nitty-gritty kind of work that you would use to have to do when using a OSS CLI option, for example, like state and log file management, which was usually very kind of tedious task to do. It also supports the same kind of standardized API or UI interface. And another very important aspect of it, it supports remote execution of your code, which is really important when running it in a team and trying to avoid stepping on each other's toes. So let's quickly look how it actually is abstracting the complexity. As we've seen in the previous slide, you can look at this as a kind of a delegation of responsibilities. So a big chunk of, like I mentioned, tedious work is delegated to the Terraform Cloud now. So like I mentioned, state and log file management is completely handled by the Terraform Cloud. So you don't have to worry anymore or define different backend providers in order to safely store and lock your state while using it in a collaborative way. it supports remote and local executions, and of course, speculative plans. If you look at the picture here, this is actually a speculative plan run from a local CLI. There are three cases when speculative plan is ran. This is if you have local execution set and you locally run your Terraform plan, or if you have ECS integration set up and you open a branch and this triggers a speculative plan as well, or you can use an API call to just run the speculative plan completely programmatically. So in this case, we see this was run locally, but we've been notified that the plan is running in the remote backend. And even though if we cancel it locally, it will still be run. And it also shows us the URL we can access in order to get plan logs at any point in the future as well. So it also kind of gives us, as I mentioned, nice notifications options you can set up, and there is a nice web UI. We're going to look in the demo. And of course, it kind of comes with a nice unified workflows. So we have the same kind of approach and structures that we were using before. And we could argue here that it's kind of changing our perspective, how we are deploying our infrastructure. So there is a shift of, as I mentioned, responsibility, who is handling all the different bits of, let's say, background processes that Terraform involves while building up the cyclic dependency graph as you're trying to deploy infrastructure. So at this point, as we see, it's kind of the off-the-shelf SaaS solution. So is it already commodity? Is it not? Let's continue with our presentation, and hopefully we can answer that question at the end of it. So let's just quickly look over the automation and pipelines. As I mentioned, it integrates well with all the major VSS providers, such as GitHub, GitLab, Bitbucket, Azure DevOps. I think others are planned as well. It's using containers as a runtime where we can specify a Terraform version we want to use or just use latest. We can use auto or manual approvals while deploying our infrastructure. And of course, variables and secrets are safely stored and can be accessed using the TFE provider resource. For example, using TFE variable resource, or we can even access the remote state using Terraform remote state data resource. It also supports private repositories and providers you might use or develop your own. This means that it's all limited within your workspace or within your organization, but you're not limited to just that. You can also use the private repository that HashiCorp is offering. There are a couple of caveats that you would need, that you kind of need to be aware of. For example, it overrides Terraform.tfvars, so it's recommended to use .auto.tfvars if you're setting your variables from your repository. And there are some special variables that you need to be aware of, for example, like confirm destroy, which is a variable you need to set in order to be able to destroy the infrastructure, or, for example, TFE parallelism for setting the level of parallelism when Terraform calculates your cyclic dependency graph. So let's just quickly look how we can start working with it. First, of course, you need to create your account or organization on app.terraform.io, where you can manage your team and workspaces. Then the good practice is definitely setting up the two-factor authentication policy, for example, like third-party application or SMS. You probably want to set up the VCS integration and trigger pipelines from your Git repositories. Then the next step is probably creating credential tokens you can use if you're running your Terraform locally. And then in your code, you need to specify the remote backend configuration in order to use the Terraform Cloud when you trigger your runs remotely, if you go for that option, of course. And just the thing to be aware of, if you're using the remote backend, workspace is automatically created for you if it doesn't exist. And of course, as I mentioned, there are different API and tokens available that you can create and programmatically control everything, with also SSH keys and policies that can be set as well. So if we quickly look at how we start doing that, first we need to set the Terraform RC file in our home folder. Specifically, we need to use credential block for the app.terraform.io and set the token that we have created or has been created for us. Obviously, this is a fake one, so it won't help you copying over. And the next thing, as I mentioned, we need to set the backend configuration. And in this case, we need to use the backend called remote. We already set the organization we're going to use and the name of the workspace that's going to be used there. So just quickly look over how the remote runs look like. So on the right here, we are seeing the screenshot when we're using the Terraform Cloud web UI. And specifically, we can see our past runs, we can access logs, have a quick overview of which runs have failed or succeeded, and we can drill into more details if we want. And on the left, there is a screenshot showing how it all well integrates with our, in this example, GitLab pipelines, which I'm going to use for my demo later on. And you can also see it all looks like a native kind of integration that you get when you use Terraform Cloud integration for VCS. So I think we have about 8 minutes left. So without further ado, it's time for demo. So I'm just going to quickly switch over to the console here. So as I mentioned, I already have my organization and my account set. And as I already mentioned, the first thing you would need to do is generate your authentication tokens. I already did that. So I'm just here showing you that this is already done and where to do it. The next thing you probably want to do is sort out your VCS provider in this case. So as you can see here, I already have GitHub and GitLab integrations sorted out in my organization, which is going to use for the further demo. In this demo, I'm going to use GitLab specifically. So if I just go quickly back, as of course, before I go back, just to show you there are modules that you can use. Those are just private modules that you can do. There is a design option or add existing module or provider. Next, we're gonna look at how my workspace looks like. You're gonna notice it's fairly empty. I mostly use this account for demoing stuff. So in this demo, we're gonna use the workspace here called demo.tf remote. So you're gonna notice here that I already did a couple of runs. First, we're just gonna quickly look. We can also have a look of the states, which is kind of nice because not only you can actually inspect your state, but you can actually see the kind of nice diff between current state and a previous state that we run. So this one was destroying an infrastructure. So this state in this example is empty now. And we have destroyed our resources here. So let's just quickly go and look at the variables. I have a couple of variables set. For example, I'm using AWS access and secret keys, so it can actually do something in my AWS account. And I am setting confirm destroy, so I can actually destroy my infrastructure at the end. As I mentioned, you can manually manage your logs. Currently, no logs are set. And of course, there is an option to set notifications, as I mentioned before, so you can be notified either by Slack or a generic webhook that you can set. We're going to use destruction and deletion at the end of this demo. So let me just quickly show you my repo here. It's a fairly basic repo. I'm just going to quickly show you the main TF file, how it looks like. So it's just a basic AWS instance resource code node. It doesn't do anything fancy, just deploys AWS EC2 instance and spins it up. So I'm just going to quickly switch the pipelines here and quickly go to the console. I hope my phones are big enough. I can actually make it a little bit bigger. So as I mentioned, I'm going to quickly show you how the integration works. I'm going to say HashiTalks to 20 node. I'm going to quickly just commit that in. So I'm just going to say HashiTalks 2020. Of course, I cannot type now. So I'm just going to push the change in directly to master because we're doing YOLO today. So if we check our pipelines now, there should be another one kicking off right now. As we can see, it's being kicked off. So we can check what it's doing. We can see it's being run in Atlas. This is the HashiCorp Cloud thing. And we can either drill in here and it will directly redirect us here, or we can use our workspace here and see what's been doing. It's going to show us the plan, and since I have the manual confirmation set, I need to confirm before it's going to apply it. And now it's starting to apply it. You can see the output is exactly the same as we are used of having it if we run the Terraform locally. So if we just quickly look at the AWS console, so you're going to see I didn't pre-record this and it's actually happening. You're going to see that the instance should be coming up in my console here. Yep, the instance is coming up and it has HashiTalks 2020 node 0 name set. So I think I'm running out of time shortly. I'm just going to let it spin up. And oh yeah, it's already finished. So just before I go back to conclusions, I will also show you how to destroy infrastructure quickly. So if we set the confirm destroy, we can actually queue a destroy plan. Of course, there is also an option to destroy the whole workspace, but it's a good practice to destroy your resources before you're actually destroying your workspace and losing any kind of state that you need to use in order to destroy those resources. So it's just going through the classical destroy plan. It's going to show us what's going to destroy here. And of course, we need confirmation for that as well, since it's not automated. Okay, the plan is still pending, so I'm not going to wait for this one and just go up. I was a little bit impatient, so I'm just going to confirm that, and it's going to destroy infrastructure previously created. Okay, just going back to my presentation, and let's just wrap it up quickly so we don't overrun our allotted time. So just to kind of conclude the presentation here, as I said before, Terraform Cloud really delegates all the complexity away from us comparing to using the CLI option. It's really good for automation and deployment workflow integration. The only thing we should be really careful about not storing or emitting secrets in configuration and logs. So this still applies when using Terraform Cloud solution. There are really some nice cooling features that are either in beta function or not free. So like cost estimation, which I mentioned, policies. There are beta running the run triggers right now, where you can chain your pipelines. There's of course some room for improvement as well. For example, when you create your workspace, the default is remote, which is usually not desired, especially if you're starting with it or have a small project. Probably people would also be happy to use custom Docker images instead of preset ones from HashiCorp upstream repo. The cloud SAML SSO is still not available. It's only available in an enterprise solution. If you're going for the hosted SaaS solution, it's still not an supported option. And of course, some of the customers have consideration regard, specifically in the highly regulated environments, about compliance and specifically certifications that they would like to get from HashiCorp before moving there. But if you start using Terraform Cloud and your organization up to 5 users, it's completely free. We just think it's a very good incentive if you start using it. And of course, to just wrap it off, we are seeing a lot of shifting left practice, which kind of tries to move testing to early stages and catch all the errors. And of course, platform convergence with multi-cloud we're seeing nowadays. I would definitely say that infrastructure as a code or even as a software, as we are handling nowadays with the repositories and testing, it's definitely becoming more and more delivered as a commodity. And I'm sure it's not far away when it's going to be available almost like a socket in every home. So yeah, that's it from me. I will just leave it with you with my contacts where you can reach me and some useful resources. I'll stay around to answer any questions that might arise on Zoom chat. And that's it for me for today. Thank you for listening and enjoy your HashiTalks further on.